Today we are going to learn about building REST APIs with Node.js and Express. By the end of this video, you will understand how to set up a basic REST API and handle different HTTP requests, enhancing your skills in server-side development.
Welcome to our tutorial on building REST APIs using Node.js and Express. In today's digital age, creating efficient and scalable server-side applications is crucial, and Node.js along with Express is at the forefront of this technology. Throughout this video, we'll guide you on setting up a basic REST API, handling various HTTP requests, and connecting to a database. By the end of this session, you'll have the foundational skills to build your own RESTful services, paving the way for advanced server-side development.
Node.js is a powerful JavaScript runtime built on Chrome's V8 JavaScript engine. It allows developers to use JavaScript to write server-side code, making it a versatile choice for building scalable network applications. Express, on the other hand, is a fast, unopinionated, minimalist web framework for Node.js. It simplifies the task of building APIs by providing robust features for web and mobile applications. Together, Node.js and Express form a formidable duo that supports the development of dynamic and efficient server-side applications. In a world where speed and scalability are paramount, these tools help developers build high-performance applications. To get started, ensure you have Node.js installed on your system. You can download it from the official Node.js website. Once done, you're ready to harness the power of Node.js and Express in creating RESTful APIs. Let's begin by setting up a Node.js project. Open your terminal or command prompt and navigate to your project directory. Use the command npm init to initialize a new Node.js project. Follow the prompts to create a package.json file, which will store important metadata about your project, including its dependencies. Next, install Express by running npm install Express. This will add Express to your project's dependencies. With Express installed, let's set up our project structure. Begin by creating a folder named src, where we will place our source code. Inside src, create a file named app.js. This will serve as the entry point for our application. To ensure everything is set up correctly, add a basic configuration in app.js to import Express and create an instance of it. This foundational setup will allow us to build and expand our API efficiently.
With our project ready, it's time to set up our Express server. In the app.js file, import Express and create an instance by calling const app equals express.next. Define a port for your server to listen on, such as const port equals 3000. Use app.listenPort equals greater than console.log server running on port $port comma to start the server and listen for incoming requests. Express middleware functions are functions that have access to the request object, rec, the response object, res, and the next middleware function in the application's request-response cycle. Middleware can execute code, make changes to the request and response objects, and the request-response cycle, and call the next middleware. Let's add a simple request handler for the root URL by using app.get/rec res equals greater than res.send hello world. This will respond with hello world whenever a GET request is made to the root URL. Now, run your server using node src/app.js. Navigate to http://localhost:3000 in your browser to test it out. If everything is set up correctly, you should see hello world displayed.
RESTful routing is a key component of REST APIs. It involves mapping HTTP requests to functions designed to handle specific endpoints and actions. In Express, defining routes is straightforward. You can use methods like app.get, app.post, app.put, and app.delete to define routes that respond to get, post, put, and delete requests respectively. For example, to define a get route for fetching user data, you can write app.get/users, rec, res, equals greater than res.send user data. Route parameters can be defined using a colon, like app.get/users/:id, rec, res, equals greater than res.send user $rec.params, comma, allowing dynamic processing based on the route input. It's crucial to organize your routes logically. Consider using separate files to manage different categories of routes, like users.js for user-related routes. This helps maintain a clean and scalable codebase. Adhering to best practices such as using clear and consistent naming conventions enhances the readability and maintainability of your API routes. GET requests are used to retrieve data from a server. In Express, they are implemented using the app.get method. For instance, to handle a GET request for fetching a list of users, you can define a route like app.get/users, rec, res, equals greater than res.json users list. Here, users list is an array containing user data. Express allows you to send JSON responses using the res.json method, making it easy to return structured data. Query parameters can be accessed via rec.query, allowing you to filter or sort results based on client input. For example, to handle a search query, you might write app.get/search, rec, res, equals greater than, const search term equals rec.query.term, res.json search results. Testing your Git endpoints is crucial to ensure they return the expected results. Tools like Postman or curl can be used to send requests and verify responses, ensuring your API behaves as intended. Post requests are used to send data to the server to create or update resources. In Express, you handle post requests using the app.post method. Begin by ensuring your application can parse incoming request bodies. Use the express.json middleware to parse JSON data. For example, to handle a post request for adding a new user, you can define a route like app.post/users, rec, res, equals greater than, const new user equals rec.body, users list.push new user, res.status 201. JSON new user. It's important to validate input data to ensure it meets required criteria before processing. This can be achieved using libraries like Joy or Express Validator, which provide flexible validation schemas. Testing post endpoints involves sending requests with different payloads to ensure your API correctly handles various input scenarios. Again, tools like Postman or curl are invaluable for testing and verifying your post request implementations. Put requests are primarily used to update existing resources. In Express, you can implement put requests using the app.put method. For example, to update user information, you might define a route like app.put/users/:id, rec, res, equals greater than, const user id equals rec.params.id, const updated data equals rec.body, // logic to update user in database res.json updated user. One key aspect of put requests is ensuring idempotency, meaning repeated requests with the same data should result in the same outcome. This is crucial for maintaining consistency and reliability in your API. Idempotency can be achieved by always replacing the entire resource with the provided data, rather than partially updating it. Testing put endpoints involves sending updates to your API and verifying that the data is updated correctly. Ensure that repeated requests yield consistent results, reinforcing the idempotent nature of your API. Again, Postman or curl can assist in testing and verification.
Delete requests are used to remove resources from a server. In Express, you can implement delete requests using the app.delete method. For example, to delete a user, define a route like app.delete/users/:id, rec, res, equals greater than, const user id equals rec.params.id, / logic to delete user from database res.status 204. Send. It's important to handle cases where the resource to be deleted doesn't exist. Consider returning a 404 status code if the resource is not found, providing clear feedback to the client. Testing delete endpoints involves ensuring resources are correctly removed and that appropriate responses are returned for both successful and unsuccessful deletion attempts. Use tools like Postman or curl to send delete requests and verify your API's behavior, ensuring it handles various scenarios appropriately.
Connecting your API to a database is essential for dynamic data management. Choose a database that suits your needs, such as MongoDB, PostgreSQL, or MySQL. For instance, MongoDB is a popular choice for its flexibility and scalability. To integrate a database with Express, you'll typically use a library or ORM, object relational mapping, such as Mongoose for MongoDB or Sequelize for SQL databases. Begin by installing the necessary package, such as npm install mongoose for MongoDB. In your application, establish a connection to the database using the library's connection method. It's crucial to manage database connections effectively, handling connection errors and ensuring the application can reconnect if the connection is lost. Implementing CRUD operations, create, read, update, delete, involves using the database library's methods to interact with the data. Follow best practices such as using environment variables for configuration, and ensure your application can gracefully handle database failures. Testing your database integration involves verifying that your API correctly reads from and writes to the database, maintaining data integrity and consistency. Effective error handling is crucial for building robust APIs. In Express, you can implement error handling using error handling middleware. This is a special type of middleware that takes 4 arguments, rec, res, and next. For instance, you can define an error handling middleware like app.use rec, res, next, equals greater than, console.error.stack, res.status 500. Send something went wrong. This middleware logs the error and sends a generic error message to the client. Custom error messages can be implemented by creating error instances with specific messages and status codes, allowing you to provide clear and descriptive feedback to clients. Logging errors is essential for diagnosing issues. Consider using logging libraries like Winston or Morgan to capture error details and request information. Graceful failure handling ensures your API can continue operating despite encountering errors. Implement retry mechanisms or fallback procedures where appropriate, minimizing the impact of errors on the overall system. Testing your error handling involves simulating different error scenarios and verifying that your API responds appropriately, providing useful feedback and maintaining stability.
Testing your API endpoints is a vital step in ensuring their functionality and reliability. There are several tools available for testing APIs, such as Postman, curl, and automated testing frameworks like Mocha and Chai. These tools allow you to send requests to your endpoints and verify that the responses are as expected. Automated testing strategies involve writing test scripts that cover various scenarios, including typical use cases and edge cases. This ensures your API handles different inputs and conditions correctly. Consider implementing unit tests for individual functions and integration tests for entire endpoints. Testing for edge cases involves identifying unusual or extreme input scenarios that might cause issues, and ensuring your API handles them gracefully. Continuous integration, C, and testing involve integrating automated tests into your development workflow, running them whenever code changes are made. This helps catch issues early and ensures your API remains stable and reliable as it evolves. Testing is an ongoing process, and maintaining comprehensive test coverage is key to building robust, high-quality APIs. In conclusion, we've covered the essential steps to building REST APIs using Node.js and Express. From setting up a basic server to defining RESTful routes and handling various HTTP requests, you've gained the foundational skills needed to create robust server-side applications. REST APIs are a crucial component of modern web development, enabling seamless communication between clients and servers. Node.js and Express offer a powerful and efficient way to build scalable, high-performance APIs. As you continue your learning journey, we encourage you to practice by building your own APIs and exploring more advanced topics. Consider diving deeper into topics like authentication, authorization, and deploying your applications to a live environment. Remember, building APIs is a skill that improves with practice and experience. Keep experimenting, stay curious, and continue building your expertise in the world of server-side development.